favorite workshop. I've been looking forward to what Alex is going to introduce us to for some time. I am Jodom Konuko, and I am presently the founder and CTO at Bitsacco. I will let Alex introduce himself.
Hello, my name's Alex. I am an application developer at Fedi and Fedimint contributor.
Good. Nice. Alex, I think at this point we are ready to learn more about how to build Fedimint in less than 30 minutes, build a Fedimint wallet without using Rust. You know, I probably were trying to use Rust in the morning, but if you can do this in 30 minutes, that would be really cool. So yes, just take it away. And yeah, if you have any questions through this workshop, don't hesitate to raise your hand, even in the middle. I think that is, we can capture feedback on point. And I will just come to you as well. Thank you. Enjoy.
Hey everybody, thank you for joining. I'm incredibly honored to be with you today to talk about the Fedimint Web SDK. So let's get started. We have a couple of to-dos. We're going to talk about the state of Fedimint development. We're going to talk about the Fedimint Web SDK and give an overview. And then we're going to do a workshop. We're going to build an entire wallet from scratch together in about 20 minutes. And then we're going to talk about some takeaways. So background, building on Bitcoin and Fedimint. We're going to talk about the existing Fedimint ecosystem and why we need yet another library. What is Fedimint? Fedimint is two things stapled together. It is a federated custody solution plus a Chaumian eCashment. So we have a custody solution that solves how to store money in a safe way. And then we attach an eCashment, a Chaumian eCashment, and that gives us incredibly scalable and private payments. And the point of this is that we have a scalable infrastructure that removes any single point of failure. In addition, it also works with Lightning and on-chain completely trustlessly and has a bunch of awesome features. Fedimint is packed with all of the coolest things you could ever want in a Bitcoin ecosystem, such as on-chain support. You have the innovative custody solution. You have privacy by default, Lightning support. You have a native protocol, which is phenomenal for building wallet applications. You have built-in backup recovery and fully auditable reserves of your custodian. Wow, look at all of the amazing features. It's the best thing ever. Best thing since sliced bread. Fedimint is awesome. In addition, we have a thriving ecosystem of libraries. We have the Fedimint client library, which is written in Rust, and this is the robust flagship library that all of the cool applications use. We have the Fedimint HTTP client, which wraps the Fedimint client and provides an HTTP module, so you can talk to the Fedimint client with an API interface. And we have a bunch of language bindings for the HTTP client, which is incredible. But we actually shouldn't just call all of these native libraries, because several of these require a Fedimint client D server to be running. So that's not very suitable for making applications. Of these libraries, these are the ones that require a Fedimint client D server. As you can see, a lot of them do. In addition, we have a thriving ecosystem of wallets. On the README of the Fedimint docs, we have a list of all of the wallets that Fedimint support or that are built with Fedimint. We have the Fedimint CLI wallet, which is a command line wallet. We have Fedi, the flagship super app that everybody here knows and loves. We have Webimint, Mutiny wallet, and Harbor. And I think this tweet sums it up really well. Is now that Mutiny has added Fedimint, everybody can shut up about Fedimint not existing. Fantastic, we're in the future. Fedimint is everywhere. But honestly, this isn't also it's noteworthy to say that of these, most of them, or several of them are written in the Rust programming language, which is noteworthy because this is not the normal language or not the normal toolkit that applications are written in. It's lower level, and most application developers don't know Rust. But of these applications, these are the ones written in Rust. As you can see, this might lead to some issues, but also we can't exactly call all of these usable. The Fedimint CLI only works in the command line, so that's not exactly usable by most users. Webimint claims that it's a hackathon project and you shouldn't use it because it's unreliable. Also, Mutiny Wallet just announced that they're shutting down, so that's not too good. Well, we still have Fedi and Harbor. That's great, but this is kind of scary. You know, Fedimint is the coolest thing ever. Why are there not more applications written with Fedimint? What's going on? Where is everybody? Again, we have all of the amazing features that you could possibly want inside of a Bitcoin system. So come on, what's going on? Where are all the projects? What's the problem? Kind of alluded to it already, but this is a graphic that describes the problem. Can anybody spot the problem? This graphic compares the learning curve for some Bitcoin tools. You can see Fedimint in the bottom center. Can anybody spot the problem? Correct. This is the problem right here. There it is. This is the problem. Fedimint is really hard. The learning curve is super, super steep. It's incredibly complex, and this dramatically limits the pool of contributors. Even on the first paragraph of the README, Fedimint is an advanced Rust project. We're always looking for experienced Rust developers to help with the core code base. So it's not the application developer's fault. The tools did not exist to build applications for normal developers. But does it have to be? Does it always have to be this gloom, difficult existence? Well, what if we utilize Fedimint's core Rust libraries, but we expose a library with a simple developer interface for application developers? This is the inspiration behind the Fedimint Web SDK. We're building eCache into the web. We have a robust, privacy-focused, and WebAssembly-powered library for everybody to build Fedimint apps. And you can check out the docs of this at web.fedimint.org, and this is what we're talking about today. The Web SDK has a mission. The mission of the project is to provide the best possible developer experience for building with Bitcoin, period, full stop. And we want to lower the barrier of entry for creating safe, robust, privacy-centric applications. The Fedimint Web SDK has several components. The first is a WebAssembly-powered client. So how the Web SDK works is that we take the Rust-written Fedimint client SDK and we build it into a WASM module and then load that into a web worker and provide an interface around this. So it's incredibly performant and built for the web. We have Lightning and eCache payments by default. As soon as you instantiate the library, you have working Lightning and eCache, zero setup required. We handle the state management for you. The Fedimint client SDK inside of the WASM handles all of the complex state management associated with running an eCache wallet. It's incredibly hard to build a robust fault-tolerant eCache wallet and keep track of all the states and not lose money. But if you use the Fedimint Web SDK, it's very, very difficult to lose money. It does all of the hard parts for you. And finally, we're framework agnostic. This means is we're a vanilla JS compatible library, so we work anywhere that you're building apps for the web. And this can be the groundwork. So any framework that you're using, any modern framework or older framework will work with the Fedimint Web SDK. So let's try to build a wallet together in 20 minutes. We're going to create a UI using AI tools. We're going to add the Fedimint Web SDK, and we're going to make it work all inside of roughly 20 minutes. Okay, let's get started. If you'd like to follow along, then there is a couple of links, bit.ly/SDK-workshop-repo. I'm going to be going kind of fast to be inside of our time window, but feel free to try to follow along if you'd like. You can also follow these slides, which will be helpful. But yeah, recommendation is not to follow along right now. Just use the recording after the fact if this is being recorded, or look at the slides of repo after we're done. So let's get started. So we have a few to-dos. We're going to create a wallet. We're going to hold an eCache balance. And then we're going to send and receive over Lightning. The goal is to create something that works kind of like Alby, just a very simple wallet that sends and receives over Lightning. So let's get started. The first thing we're going to do is clone our repo. I have this already set up for us. We're going to install dependencies and run pnpm dev to start the dev server. So this is the project. I'm going to run pnpm dev, and this will spin up the development server, and I can check that we do indeed have a project. Right now, there's nothing here. It just says hello world, but we're just getting started. Next, we're going to follow the Getting Started guide from the Fedimint Web SDK docs. I mentioned that we have a docs page. So this is web.fedimint.org. It holds all of the information you need to learn about the Web SDK and to build apps. We're going to go to the Getting Started guide. Getting Started guide. We're going to follow this. We're going to add the Fedimint Core Web library to our project. So let's do that. We're just going to run pnpm add Fedimint Core Web. Then we're going to go to framework setup. Because we're using WASM, we need to update the configuration of our framework slightly just to make WebAssembly work. This example app is using something called Vite.js. So let's just go to the Vite example and follow the example. So to use WASM in a Vite project, we need to install the Vite plugin WASM plugin. So let's do that. We're going to install Vite plugin WASM. And we don't need this line, but let's update our Vite config. So this is one configuration file that we need to update to make WASM work in the repo. Let's just grab this whole thing and paste it in. We can remove the top level await, but leave in the WASM. So all this is we're installing the WASM plugin, putting it in our plugins. We have to define some worker settings because we have a web worker, and then have the WASM plugin here as well. And then we're going to exclude optimized depths, the core web. But again, it's not super important to follow this. It's all in the docs. Great. Next, we're going to create a Fedimint wallet. So let's actually write some code. We're going to create a wallet.ts file, and we're going to import the Fedimint wallet class from the SDK. We're going to create a new wallet. We are going to attach it to global disk. This is just for debugging purposes. You wouldn't do this in production, but this gives us access to the wallet inside of the console. Then we're going to set the log level to debug and export the wallet. Just for convenience, I put all the code inside of comments on the slide. So if you look at these slides, then you should be able to follow along pretty easily. So let's grab that code. We're going to go back to our code, and we're going to create a new file called wallet.ts, and we're going to paste in this code. Now, so we have the dev server already running. Inside of app.ts, we can import this wallet. Let's see, yeah, export default, and we're just going to console.log wallet. Let's just see if this is working in the browser already. So fantastic. We can see some logs already coming through. We can see that our worker is being instantiated and the library is being initialized. And we actually have the wallet already working. So we attach it to global disk, so we can see that we have the wallet in the browser already. And that's great. So the library is working as expected. Next, let's create the entire UI using AI tools. If you haven't heard of Vercel v0, this is rocking the front-end world. It can build UI components using prompts, and then you can install those components into your application using one command. So I have a small prompt written that we're going to use. The prompt is, I want to create a UI for a basic wallet app. The app should use React plus Vite. It should have a balance, a send button, which opens a simple form with one string called invoice, and a receive button, which opens a simple form with one number field called amount. Dead simple. So let's see what Vercel v0 does. This is Vercel v0. I'm going to paste in our prompt and hit go. So Vercel v0 is thinking. Great. It's going to help us make an app. It's explaining how to set up a project. That's great. And it's writing some code for us. Kind of cool. We already have mock receive functions, mock send functions. That's great. We have a bunch of UI being built for us. That's awesome. And let's see how it looks. Interesting. Index can't be found. Let's make sure it exists. So let's hit this button, fix with v0, see if the AI tool can fix our problems. Okay, it's writing some CSS for us. Looking good. Modifying main TSX. Let's see. Looks like something's going wrong.
Hey, Alex, could you bump your resolution a bit?
Yeah, no problem. How's this?
Looking better.
Great. Looks like we're hung up on something. I'm going to try to retry. Show of hands in the audience. How many people here have messed around with these AI code tools before? Anybody?
Yeah, if you've used
No
the
one.
agents to write code stuff. Nice.
Yep. Okay, this looks better. We have a send form, a receive form. We're pulling in UI components. Let's see. Oh, fantastic. We have our entire UI built. So we have a wallet, we have a balance, we have a send button with an invoice field, and a receive button with an amount field. Oh, that's great. Our entire UI is basically done. One really cool part about Vercel v0 is that it gives you a command, or let's see, add to codebase. This add to codebase command gives us a npx script, and we can go back to our codebase and we can add this component to our library, or to our application. So we're going to paste in this command, and it's going to pull that component from Vercel and stick it in our application so we can start using it immediately. Oh, it's pulling it in. Yeah, Jodom, how does the code look right now?
Well, looking promising. I see a hello world, and I want to use the wallet.
But is it awesome? Is it visible? Can everybody see the code itself, or does it need to be blown?
The folks at the back 2 rows, can you see the screen? You can see the screen? Good, yes. We have side screens on here as well, in case you need to look closer.
Fantastic.
Right.
Awesome. Okay, that's great. So it looks like we have our code. We can open up the components folder now, and we can see all of these AI-generated all of this AI-generated code already. So we have a function called app. This is pulling in some components, and interesting. Let's see. It looks like it got this a bit wrong. I think we need to just pull this app TSX outside. Let's delete the app TSX that we wrote and pull in this one and put it into our main folder. See if this works. Great. Now, if we go back to our app, let's see what it looks like. We're missing UI button. We do have button. Live debugging. Interesting. We have button from @components/ I think I see what's the issue. We just need to change that to a dot. Try again. We have @components UI. This needs to be dot components. We also have inside of these, let's change these to dots as well. Or no, this needs to be dot, let's see, dot/UI. Send form, it needs to be changed as well. Yeah, about 1 in 5 or 6 times it gets it this wrong. This is usually it gets fewer things wrong. So we have card. Let's change this to dot. This is saying it needs some utils. Let's see. It should be dot/lib. Dot/lib utils. And then we have another @ sign to set a label TSX. Needs to be .. .. See input.tsx .. .. Try again. Button TSX. Yeah, all of these need to be changed. Okay, an hour of debugging later, we have a wallet in our app. Fantastic. We can see the send field. We can see the receive field. Our UI is done. All right, apologies for the technical difficulties, but we are rocking and rolling. Next step, we're going to open the wallet. We have some wallet code here. So this, what this does is it calls the wallet.open function. It checks to see if the wallet is, if that was successful. And if it was unsuccessful, that means it was the first time that this loaded. So we need to call the wallet.joinFederation function. And then if it was already open, then we don't need to do anything. So let's just copy this code, go into the app TSX, paste it here. We also need to re-import our wallet from /wallet. We need to add the useEffect hook from React. And yeah, this is the federation invitation just from the testnet federation. So let's see if this works. Great. So we can see the wallet.open, success is true. So we have a functioning wallet. At this point, our wallet actually completely works. We can call wallet.balance.getBalance, and this will get a balance. All the functionality for the wallet is done. The library works. We just have to hook it up to the UI. Actually, and it's probably worth showing. What's happening behind the scenes is that we've created a database inside the browser instead of IndexedDB called Fedimint default. This is just the default wallet, and this contains a bunch of arbitrary data that's being used by the Rust client. In addition, we can see that we have a web worker running that contains, that's coming from the Fedimint core web library. So this is all working as expected. Let's keep moving. Next, we're going to subscribe to our balances. So right now, the balance that we see in the wallet is fake, but let's get a real balance. So we have, with the SDK, the subscribe balance feature. Typically, when you're creating a wallet application, you have to pull your balance to keep it updated or refresh your balance all the time. But this makes it very easy. There's a subscribe balance helper. So anytime that there's an update to the balance, this callback function will be called. So it will keep our balance up to date always. Let's do that. So let's paste in this code. Formatted it. So yeah, we have the wallet app. We've set it up. We have, we're calling wallet.open. We are subscribing to the balance and setting the balance. Now let's grab that balance. And okay, we've already put that into our code. So this should be up to date already. Look at that. Okay, cool. So we have a balance. It's 0.00. Maybe while we're at it, let's go to the balance component and get rid of this dollar and maybe add, let's also get rid of the, get rid of the decimal and then, or let's make it 250 and then say sats here just to be clear. Okay, and it seems like it's flickering. So let's change the balance. It looks like it's setting it to 1,000. Let's make this 0 by default. Great. So now our balance works. Next step is we're going to handle creating invoices. So we have another function for handle receive. This calls wallet.lightning.createInvoice. So first it grabs the amount from the input field. It calls wallet.lightning.createInvoice, and it will create an invoice from the library. So let's grab that real quick. So we already have this mock handle receive function. That's quite convenient. But let's replace that with our handle receive function. So we have we have this amount. So we want this to be e.submit. target dot value dot amount of value. This is a form event. Handle receive. What did it have before? Let's just grab this. Paste that in here. We have an amount coming in. We have this amount. We're calling, we can get rid of this. We don't need to do this anymore because we already have our amount. We're going to call amount. The create invoice requires millisats, so we're going to multiply by 1,000. Then we're going to take this invoice and set our generated invoice. So we need to create these fields as well. So let's create a generated invoice. And we also need to clear our amount. So, or we don't have an amount value, so that's okay. So we can just get rid of this. Now, when we set this generated invoice, let's go back down below our receive form and just add this in. So we're going to say if our generated invoice exists, we are going to paste the invoice in our app just like this. So let's go back to the example app. We're going to hit receive, enter in an amount, and this should generate an invoice. Hey, look at that. We have Lightning. So now we can grab this invoice, and this is already payable. So to pay this invoice, we can just go to the faucet. You can go to alpha.fedi.xyz to get access to the testnet faucet. We can take our invoice and paste it inside of this receive sats box and click receive. Enjoy the test stats. Let's flip back to our app. As soon as this lands, we should see our balance get updated. Let's see. Let's see, is this coming? Okay, here's our balance. Great. So this already works. Awesome, we have receiving over Lightning. Next, let's do paying over Lightning. So we have another function that's very similar, the handle send function. We are going to call wallet.lightning.payInvoice and pass in this invoice, and we're going to pay an invoice. So let's go to our mock handle send function, paste this right here. You have to modify it. Yeah, the code is a bit different than the last time I generated it, so we have to make some changes. And we are going to pay it just like this. So let's see if this works. So now we have the send field. We can, inside of the test of federation, we're going to generate an invoice to test. We're going to copy this invoice, paste it here, hit send, and let's see, pay result, pay type. It is pending. Did this get paid? Let's see. Okay, it did actually get paid. Our balance is not updating, so we don't see it live, but the payment did succeed. Yeah, not sure why that's not getting updated, but that's okay. Anywho, so to summarize, we have a wallet app, we have a balance, we have a send feature and a receive feature, and they all work. So, and just however long that was, in 20-ish minutes, we have a wallet, a fully functioning Lightning wallet, which is pretty cool. And just like that, we just did it. We just created a Fedimint wallet inside of half an hour. And we didn't have to touch Rust once. We just used normal, friendly application interfaces, and fantastic. We just increased the total number of Fedimint supported wallets in the world to about 5. Yeah, there's not many in the world, but now that we have the Fedimint Web SDK, we're going to see a lot more wallets popping up. So if you want to add to this number, the global wallets, you can bump the total number of Fedimint wallets in the world by a significant percentage just by implementing this today. So now, that's all I have. Jodom, do you want to talk about your work with Bitsacco?
Yes, the correct count for Fedimint wallets is 7, because at Bitsacco we build 2 more. And yeah, I introduced Bitsacco earlier today. And essentially what we are a savings and credit cooperative organization that allows you to do personal or group savings, Chama savings on Bitcoin. We build exactly on this technology that Alex has walked us through today. And Alex, if you can jump to the next slide. Yes. Again, it's a simple setup on top of these protocols on Bitcoin. So we build on Fedimint, we integrate with Lightning, and Fedimint already comes with a definition of how you connect those 2 protocols, and all of that is on Bitcoin. But exactly how we do it, I mentioned that I added 2 wallets to the count Alex gave us. Alex, if you go to the next one. Yeah, and so here, just as a highlight is, there's a number of things we do to run Bitsacco. Sorry. There's a number of things we do to run Bitsacco as a product, but we have 2 Fedimint wallets where if you look at the Chama savings feature, it essentially is a Fedimint wallet that is useful for 2 or more people. Yeah, the formation of a Chama, which is an informal savings. And the personal savings, we also can allow an individual to do exactly the send, receive, on Fedimint and Lightning. So that's it, and I'm really, really excited about this because it allows us to build a product like Bitsacco like super, super fast compared to all the hurdles we've had to experience with a new protocol like Fedimint in the last 2 years. So I'm excited to see you all try it out in your own scenarios. I am excited to see you all contribute to Web SDK and to contribute to other things built on Fedimint and Web SDK. Thank you, Alex. Yes, and Alex is gone, but that is the end of our workshop. If you have any questions, can you bring back Alex for questions? Yeah.
Yep, I'm still here.
All right, cool, cool. Any questions on this? Yes.
So during the demo, I realized that we could just go straight to testnet networks. So I wanted to ask if the SDK is customizable to switch between the networks, like testnet, regtest, something like that.
Yes, absolutely. So in order to change networks, you just have to connect to a federation that is running on a different network. So if you want to connect to a different federation, you can go to bitcoinmints.com, bitcoinmints.com, and you can see an example. Yeah, we can filter by just Fedimints, and we can see that there's several federations you connect to. We connected to the MutiNet Signet Federation, and that's why we were in testnet, but all of these are in mainnet. So yeah, to connect to those, you just call join federation with a different federation invitation.
Maybe bump screen
yeah,
a
these
bit.
links right here.
Bump the screen.
Yeah, sorry. Absolutely. So yeah, we connected to this federation. We can see Fed, this is the invite code. To connect to another federation, you just copy the invitation of the other federations. There's several to choose from. So yeah, the network is determined by whatever the federation is on.
All right, awesome. Any follow-ups or any other questions? Raise up your hand and I'll bring the mic to you pronto.
Thanks. So I'm Christine, and I'm keen on the tech behind it, and this is really cool. My question is, so this looks really efficient to build it out in 30 minutes. How does Fedimint Web SDK ensure scalability and security for the developers looking to implement this? Just on the larger production environments and stuff, because I feel like it might be fast, but questions around perhaps efficiency or like memory, things like that? Like if it gets heavy, how do you handle that when looking to scale? Yeah.
Fantastic question. So a background on Fedimint. Fedimint has been around for about 2 years, and until recently, it's been the only applications being built were in Rust. So there's been thousands of intense engineering hours being put into the Fedimint client SDK written in Rust to solve these problems that you're talking about with scalability and reliability. So all the Web SDK does is it takes the Fedimint client SDK written in Rust that has all of these engineering hours put into it, and it bundles it into a web worker. So we're borrowing all of that engineering from the hardcore open source Fedimint team, and we're exposing it through a web interface. So yeah, the result of it is that the developer, the application developer, doesn't really need to be all that concerned about the reliability because the Fedimint or the Rust SDK is so good. So yeah, it is built to scale. Does that make sense?
Yes, it does. I'm guessing it also translates to the security side, right?
Yes, Fedimint is built with an adversarial actors in mind. Yeah, so this is the exact same tech that's inside of the Fedi app. So yes, there's been a lot of consideration over the past 2 years into all of these points.
Thanks.
I'll just add on to the very concept of conception of the protocols. Like you start off as a federation where you want to distribute keys and the security of the Bitcoin among a key set, among a group of people. That is, that is at the root of it. And then you build on top of that. You build ways of people to build like wallets on top of that. But that has been in Rust so far. And as Alex just put it, now just translating that, adapting that to other platforms. So be it the web, be it Node.js, be it you want to build Flutter. I know, like Flutter mobile devs. So that's really coming, and it's exciting to see. Yeah, cool. Any other questions? We have a lot of time. We have 10 minutes. You can take your time. You can ask all questions. Yeah. Don't let Alex go, and you go back with your question.
So good afternoon. My name is Ian Masharia. I have, maybe you can say it's a stupid question, but let me just ask. So what other tokens are supported on the Fedimint wallet?
Yeah, so Fedimint is a Bitcoin-only protocol. It works with a multi-sig or a federation that backs a Bitcoin wallet. So it's only Bitcoin.
All the numbers you saw there are Bitcoin, and it's Bitcoin only. Thank you. Yeah. Any follow-ups?
Yeah, actually, maybe another thing. There is people are working on something called the stability pool module. So with Fedimint, there's a feature where you can create a synthetic derivative asset. So for people that want to hold dollars in their balance, they can inside of Fedimint they can hold a dollar balance. Yeah, this is experimental. It's still pretty early, but people are considering the idea of using this for holding dollars.
Yeah, I have a question. If like the stability pool module on Fedimint that you just talked about, how would you add that to the wallet that we just built?
Yeah, the Web SDK right now does not support the stability pool module. This is an experimental feature that is not available right now inside of the Web SDK. Yeah, the Web SDK is a work in progress. It's an early project. We will get to adding that in the future.
All right. Just any questions? Last round. All right. Thank you. Thank you, Alex. One more.
Yeah, my name is Williams. So my question is, for SDK, what is your primary goal? What you aim to achieve? Yeah.
Yeah, great question. The goal of the Fedimint Web SDK is to provide the best possible developer experience for building on Bitcoin. The rationale is that people are going to build the tools that are the easiest to grapple with and the easiest to use, and we want more tools to be built with privacy in mind and we want them to be built safely. So we want to provide people with a robust toolkit that solves these hard problems for them and give them a super simple developer interface. So that's the goal. Yeah, great question.
Yes.
I can see, oh, hi guys. I can see the docs are work in progress. Are they open source? Is there a criteria to join to help out?
Absolutely. Everything is open source. You can go to, it sounds like you found the docs, so web.fedimint.org. Here are the docs. If you want to see all of the code, just go to the upper right, click on the GitHub link right here, and you can see the repository for the Fedimint Web SDK. It's all open source, all of the different packages that are involved. You can see the structure. If you're interested in contributing to the library, you can go to the docs and go to the contributing guide. There's a contributing guide for anybody interested in helping build the SDK.
Nice. All right. Before I return the mic, any popped up questions? All right. Thank you for your time, Alex. This has been really wonderful. And I'm looking forward to all the stuff we build on Web SDK, the community wallets, the localized solutions. Yeah, contribute to Bitsacco, contribute to Web SDK. Thank you for your time.
Yeah, thanks so much. It's been an honor.
Okay. Fedi for the money, Fedi for sticking to time. Thank you so much. We'll just have to wait for the other team members to close and come back. I'll just go and check out what you're doing and we can continue from there. There's no DJ, so play music in your ears.